Приветствуем. Рафаэль Риалди. Громко, громче, громче.
Thank you very much. So, I will start introducing myself. I am an MVP since 15 years. Oh my God, it's a long time. And I am a consultant. I also drive my own company. It's a kind of instructing and teaching for me, understanding problems that comes from different industries. I know when you go to a new company that drives a different kind of business, it's extremely interesting to see how they drive differently the things that are pretty much the same in other companies. And the problems are slightly different, and you have to solve basically the same problem from a different perspective. So I enjoyed it so much to go there to resolve problems in the financial space, for example. Just kidding. I mean, the racing car is definitely the one that I love it most. It's something unbelievable. They have to go in production immediately, right? After one day, they have to go there with the new stuff, with the new fixes, the new bug fixes, and so on. And also, I am a trainer and speaker in many conferences. I travel around the world. I have been in Siberia a few weeks ago for CodeFest. It was amazing to see so many people there and discussing with several kinds of technologies. It is a conference that is not focused as this one with .NET, so it's totally different. But I enjoyed to see discussion with other technologies and other experts in the zone. And by the way, yes, I do care about security, so from time to time I'm the crazy man who wears the bandana with the pirate flag and so on, so I enjoy that thing. Let's talk about code analysis. I mean, code analysis is something that happens when you have just the source code. You don't have to run anything. So we won't hit F5 of the code that we are going to analyze. There are no tests, basically. There are nothing. It's just your code. You are progressing in writing your solution, and you are going to see something that is provided directly from the IDE. Typically, this is the kind of experience you have. So you open Visual Studio, you write some code, and you start having squiggles. You have the IntelliSense, the code completion. You have a lot of things that come from the IDE in order to provide a better developer experience and to understand how your code is going to work, because it's a kind of prediction of what will happen at runtime. But you are still not executing anything. You are just observing and making a kind of code review. One of the most interesting things that you can refactor things, because refactoring is something very interesting because it's not just based on the syntax, but it's also, there is a symbolic information that allows you to understand where did you use all the symbols across your projects and the entire solution. So basically, you have the semantic model. And the semantic model provides a lot of interesting information. So I started thinking, why can't we use these informations to have more and analyze our own code to provide a better developer experience from the business perspective? I will start with a simple example, and then we will raise up the bar as soon as we go on. Basically, we are going to leverage the Roslyn API. Roslyn is your compiler. If you are using either C# or VB, you are using Roslyn because the csc.exe is Roslyn. So you are compiling your code with Roslyn. The good information is that, the good news is, we now can look into the compiler because Microsoft opened up this black box a few years ago and exposed all the APIs. The bad part is that those APIs are not that well documented. And so how many of you tried to use the Roslyn APIs, for example, okay, a bunch of you. The other ones probably tried for 5 minutes and then gave up because it's a kind of mess to understand what is going to happen. But it's not that bad. You have to kind of enter the mindset of what you are doing. So it's not that bad. There are many services that are offered from the Roslyn API, like formatting the sources is really straightforward. It's a matter of just one line, and you obtain the exact indentation. And by the way, is the one that I use in my own PowerPoint to make the formatting nice inside my PowerPoint, because I created an add-in that as soon as you paste some C# code, automatically loads the compiler and format the code accordingly to the rules that I decided. It's fun. I mean, having the CSC compiler inside PowerPoint is something quite strange. And during the IDE, we have these suggestions. We have these error findings. We can refactor our code according to the suggestions. We also have the code fix. And the code fix are something that is very important, because if there is a solution, it's a possible solution, you can offer one or more code fix for every symptom that you found in the code, and you can decide if it's worth to apply or not. And we will see in a moment this. The good part of the analyzers is that you can also execute them on the build servers. So you can enforce this stuff exactly as we did, or maybe you don't know, but as we did with the style cop. With the style cop rules, you can go to the build server and make a gated check-in, so that either at the check-in or during the build, you can make it fail if the code has something that from the textual perspective, from the syntactical and semantical perspective, does not work. So we are not yet at the point of running tests. We are far before, okay? So the idea, the inspirational example, is a new feature that is coming with C#8. And you know that there are still discussions, so it's not finalized yet, but you can download the preview and see with your own eyes that you will receive an error if you declare a string, for example, just because it's a reference type, not because the string is special, and you start using it before checking for null. Okay? Unless you declare in a different way that I don't want to drill in it at this moment because it's not relevant to our conversation, unless you make a certain declaration that are relevant for C#8, you are not going to be allowed in certain cases. You can turn it off or on. It's not really important. You are going to receive, if you want a warning or an error, if you use a variable, a reference type that has not been initialized correctly, or if there is the chance that this reference type is null. And how can we, this is a kind of new rule. I mean, how can we enforce this rule without modifying the CLR? I mean, is something going to happen inside the .NET that it's modifying entirely the reference type space? Of course not, because otherwise the retrocompatibility is thrown away. The idea is to leverage this code analysis thing to understand if something is possible that can happen to your reference. If there is any chance that your code will execute, will access a member without initialize properly the reference, there is a possible null reference exception. And so the compiler is going to warn you, but again, is a code analysis perspective. So it's something that is going to warn you because you have a potential null reference exception. So this is just an inspirational example. And so I wondered, why can't we use this stuff to enforce our own rules that are domain specific? It's not something that is language-wide, so it's, let's call horizontally, so that spans all over any business, but is specific to our business. And one of the most simple examples that came in my mind is the serialization example. We all know that there are times in which that you have an entity, and you don't want that the default constructor is called just because in the constructor you have to do something with the complete parameters. So you don't want to have a special type. You want to have a complete type with all the parameters and all the properties correctly initialized. They don't want just to have a new customer open and a close bracket and having something that everything is null. Okay, is something that it does not work well in your business. At least it happened many times for me. The solution is, of course, to create a custom constructor. So you simply specify all the parameters with the customer that specify ID and name and so on, and you are done. But there is a problem that this way you end up in having the problem with your serializer. And so you begin screwing up with the JSON serializer, with the JSON converter, because you have to be customer aware in your deserialization, otherwise it will screw up. There are other solutions like adding attributes, and JSON.NET provides several additional workarounds for this. But you end up having dependency that you don't want to, and so on. So the basic point is we should really go with the custom deserializer, or we can do something during development time. And the answer is very simple, because we can go to this sample solution and, for example, having this very, very simple logic that is create customer, and then create a customer, and then make this, this entity happy, or this one, or even this one. And we just want this to be valid, while the other, it's better that we don't use, because if we forget these two properties, we are screwed up, and our logic is not going to work. So what I'm going to do is to add an analyzer that I already created. I will show you in a moment. That once loaded will give me a developer experience that provides me some squiggles that you can decide to be either a warning or an error, depends on you, of course. And the default error, the default warning is, you can see from here, default constructor are reserved to serializers, which is, of course, a rule that doesn't exist in C#. It's not something that makes sense in a general case, but can make sense to your specific domain, okay? It's not something that I have to recommend in any case, and not a solution that will be always this the perfect solution, but it's definitely interesting to see that you can provide this kind of solution. And also, even if you initialize the entity this way, of course, we are using the default constructor, and this will trigger the error in the same way. And the kind of solution that I created in this analyzer is simply this, the domain model constructors. I register for an operation, which is the object creation in my analyzer. And the analyze operation is going to receive as a callback any kind of statement that is of type new something, okay? And it's up to me to find if it's the correct one or not. So I know that the kind of operation is an object creation, so I can cast the operation to this one. I take from the metadata the interface identifier, which, by the way, is a sample library iDomain identifier, a simple string. And then we'll obtain a iNamed type symbol. So I obtain a symbol so that I can match and see if the symbol is exactly the one that I am analyzing. So I am not disallowing the default constructor for any type, which will be, of course, wrong. I want to enforce the rule just for my type that implement an interface, which, by the way, is empty. It's just a tag, okay? It's not something that contains members to do anything else. If you want, yes, but it doesn't matter. It can be absolutely empty. Or if you prefer, can be an attribute, okay? It's up to you to decide how to recognize the exact types. An interface is quite a good solution for this. And if the type that I am analyzing, which, by the way, is the type that is going to be constructed in all in the interfaces contains the interface type that I am searching, okay, I am going to apply this diagnostic. And so I am just checking that I want to enforce the rule if I have no arguments, because the default constructor is there. And so I find the location of the syntax. I create the new diagnostic with the rule that I just created in my code, and then I report the diagnostic. This makes the squiggle appears in the code, okay? And if you want it to be an error, it's okay. It will be an error. It's up to you to decide what you want to do. And that's very simple. I mean, something that you can do very easily. And what about going a bit on a more concrete example? Let's take an example where you have an SDK that push commands and events on a bus. And I want to send either a command or an event. In the newer architecture, I don't want to lose time in explaining what is the case specifically, but it is very common to send over the bus events and commands. And you basically have just a push from the bus perspective. It does not make any difference. So you will, of course, serialize this stuff and send over the bus, deserialize over on the other point, and is done. But probably these two APIs, send and publish, will do slightly different things because internally you can have the priorities of the queues and many other parameters that makes a difference. So maybe they are broadcasted or sent to a specific endpoint. So the first case is simply, I want to define my bus manager with publish an event and send with a command. And that's perfectly fine. I mean, it works very nice. The problem is that you end up in defining an interface on which everyone will take dependency, and we know that dependencies on large projects are definitely a problem. And maybe in a later time, you end up in having an interface which will need to be shaped slightly differently. And so, yes, it's an A command, but I have to add these members. Or maybe I don't want these members to be there. Or why should I care that I have to shape my command? I want to accept anything to be a command, because after all, and we end up in making philosophical decisions which are the worst from the design perspective, okay? So I don't want to discuss the case. Maybe half of you agree with me on this discussion, and maybe not, okay? But the point is, that depending on the domain, you may have decisions that you cannot take at design time, okay? It's something that is difficult. So the only way where you can get rid of the common interface is to define the object. I mean, why not? And the reason why not is the reason why we don't use JavaScript, right? So we love the type thing. And it's definitely a good solution, because also many JavaScript developers transitioned to TypeScript for a reason. Just to have only at design time, not later, it doesn't matter, but at design time, we want to have the types, right? So the point is, I can still define the object, but I can also give a better user experience by providing another analyzer which squiggle when I try to put an event on the send or to put a command on a publish. And this is a pretty good solution. I mean, why not? After all, we are providing the types just for the developer that is using that API. Because at runtime, it doesn't make any difference. So if I can stop the developer at compile time, it's good. And not only I can do this thing, but I can also fix, and you see the suggestion to replace the send with publish, and OK, I just fixed the logical error, the domain-specific error, okay? I want that my SDK is used this way. I am driving, I am helping, I'm giving documentation to the developer to use the SDK in the correct way. And the implementation is pretty straightforward. I mean, there is really nothing so complex. There is an analyzer that basically knows about various types. So I know about the IBUS manager, that is the type that will expose the send and publish. I know that send is for iCommand, and the parameter is index 0, so this is the first parameter. And the publish is associated with the iEvent, and the index of the arguments is 0. So I register my operation with the invocation, which is basically a call, okay? We are invoking something. And when I find an invocation, I know that I have an invocation operation. And this, I take the data, so the method name, the method symbol, and the type, the bus interface from the metadata, and so on. And I go to check what's happening there. So if the type is the correct one, because I don't want to apply this rule on all the types that I am looking at, I simply checking if the argument's length is greater or equal, greater of the send parameter index, which is, by the way, 0, we said. And I have to check the argument. So I have the semantic model that is the one that converts, let's say, the syntax in symbols, okay? Give me this additional information that allows me to understand what the specific symbol is telling me. And then we analyze the symbol. And if is mismatched, is substantially the argument is not null, is not of the correct type, and does not contain this type, because it can be derived or implemented the interface in any way. Okay, at this point I take the location, I take the diagnostic, and report the diagnostic, and the squiggle, the green squiggle, is showed to the user. And the same, exactly the same code applies to the publish method. On the other side, when I click on the light bulb, I have the code fix. And the code fix substantially receives the information from the diagnostic, from which I extract the span, so the interval of the code, the text of the location. And I register the code fix so that the change bus method is called with all this data, including the cancellation token, which is very important because everything that happens inside the IDE must be asynchronous, of course, and must be possible to be cancelled. And so the change bus method basically takes the same information that we took before in diagnostic. We have to search then again. And once we have the invocation, the call that we found before, we extract the member access. The member access is substantially when there is the dot to access a member, okay? So we have the left side, which is the variable which we are accessing. The member name is the name of the member, of course, and the arguments that are the list of the arguments that are passed to this method. At this point, once I have the old ones, I have to create a generator based on the current document. So I created the code generator, and I start generating new code, okay? So the first thing is to call my own logic, which I don't want to drill into because it's clueless. I mean, it's just my logic that say, if you find a send, there must be an iCommand. If I find a publish, there must be an event. So it's just to find the correct couples, so the tuples that are important. So the new member name suggested for the argument that I found in the code is the new member name. And so I create the new member with this identifier, thanks to the generator. Then I create the new member access expression where the left side is the same and the new, of course, is the new member. I create the invocation expression, and finally I replace the node on the root. And when I return the updated document, I'm done. So I have the replacement. It's not that bad. Now, a poll. Do you agree as a good solution? Who agree? Okay. Not too much. I still didn't convince you. But I want you to take some time and let's see. So, this is nice. And there are the classical analyzers. After all, there is nothing so super new. In fact, the analyzers are there for a while. I mean, it's not something that is tremendously new. And what we have seen now is that the IDE is walking your syntax tree. Is the Visual Studio, if you want, it works also on Visual Studio Code, by the way, calls you and informs you about the nodes that are found while you are writing code. So it's exactly that scope. And it's a very restricted scope. So you cannot really analyze by yourself the entire solution. You cannot walk whatever you want. You cannot go and have a kind of big picture of what's happening inside the solution. And that's pretty bad because, of course, there are many other information that can be relevant to what you are executing. So, for example, if I want to to know what has been executed, potentially executed, before a certain call, you have to go back in the code. So if you ever did a code review, you know that you start from a specific point and you end up to go in a totally different project, and you walk by and you spend entire days in walking the code by hand, either with F12 or if you use a Sharp or other keystrokes, it doesn't matter, but the point is you have to walk the code to understand what's exactly going on. So the analyzers are pretty close to this because they cannot see the entire solution. And so my solution is instead to write a custom tool. So basically the same API, but you start from a console application, and that can be run, of course, on the build server or in standalone, if you will. The first thing that we have to do is create a console application, for example, but it can be also a graphical interface, of course, that use this build locator that basically wraps the work to find the correct version of MS Build. You know that versioning of MS Build is kind of mess, so this is the correct NuGet package to start from to find the correct MS Build stuff. And once you have compiled the solution and there are no errors, and this is done by Roslyn because Roslyn is our compiler, is our everyday compiler, we process the syntax, and of course we extracted the semantic information with our code. What we are seeing, what you are going to see is how do we walk the graph. So there is an important information that I have to give to you because it's very, very relevant. When you walk the graph statically, it's totally different than walking the graph at runtime. So for example, when you have a call that contains a try catch finally, in a static call, you don't know what is going to happen at runtime. So potentially, you are going to execute both the try and the catch and the finally. But maybe your test doesn't never throw, and so you will never end up in testing the catch, okay? The advantage of the code analysis is that you always have code coverage that is 100%, because you end up in visiting all the nodes that are ever possible, even the ones that are potentially illogical. Did you ever experience the classical case? How is that possible? You know that, no? And it was supposed never to go there. It was impossible. No, 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 no. And your friend on the other desk, and no, it's absolutely impossible. We know that it's possible because the logic is the logic. I mean, there is always the chance that something happened. The advantage of the code analysis is that visiting the tree, you will end up in having Yes, this crudity, I mean, it's a crude information where you visit everything, even if it's potentially illogical, okay? Unless you do a specific check for constants, I will visit also the while false, just to understand between me and you. So if you have while false, invoke that, unless you check specifically, and it's possible to exclude that part in code analysis because it's a constant. So when it is a constant, it's done. But if it is inside a variable, and there is the chance that anyone can modify that value, that Boolean value to true, you will receive the visit, okay? So the most important part is that when you want to walk the tree, you have first to start from a certain point, which is the point that you want to diagnose, and then you have to walk up the tree. Why? Because if we have here something that is relevant to you, maybe before, maybe here, it happened something that is relevant and can make some changes at this point. So it's basically, we have to reconstruct basically the timeline of execution of everything that can be potentially executed. Okay? So when the application will start, if it starts in this node, we'll execute this first, and then this, okay, this one, and then this, and then this, and so on. So it's absolutely important to walk up the tree. And this is done very, very easily because in Roslyn, we have this find colors async that is a kind of a shift F12 that gives you all the reference that will invoke that specific method. And we will see it in a moment. And then we will down the path, because at this point we want to see every node that can be potentially involved in our call. But if we start from the very beginning of the tree, we will have exactly the whole graph that is relevant to the method that we picked up at the beginning. Okay? And this is basically a recursive call, because as we will see in a moment, we are inside a visitor, and this is offered by Roslyn, okay? And as soon as we find an invocation, we ask to Roslyn, okay, I found an invocation, and this member that I am invoking, is it available as a declaration? So do I have the source for the declaration? If yes, I will recurse, and I will start again in visiting it, and so my chain is completed, and I will end up in visiting all the graph. I will show you in the code, which is far better. So let's close this part, which is not very interesting now. Okay. I have this first scenario. I will skip this build helper, which basically deals with the MS build stuff, and give me the chance to open a solution entirely and ensure that it's compiled, and give me, thanks to this my helper object that it called the inspector context, makes the compilation available and give me the symbols for all the possible nodes. This is a kind of helper that avoids to mess up every time and asking again and again the object that I needed to. The first visitor I want to show you is the get members. So the get members is very nice because it's a visitor that allows me to extract all the members that are included in my solution. And this is a kind of first interesting thing. From this, I basically have this static method which instantiates the visitor and cycle across all the project of the solution and add all the members extracted from that. And so basically, recursively, it's called in all this part until I begin visit my visitor. This is the member extracted visitor, is the same guy, but this is static. I'm renewing it because it derives from a C# syntax walker that gives me the opportunity to walk a syntax tree, which is very, very good. What I did, I simply overrided two methods. So I overrided the visit method declaration and the visit property declaration. And once I have this, I can see all the declaration for property and methods. That's it. I am not interested in all the other syntax, and there are very, very long list on this. So if you make override here, you will see that the list is super long, okay, with all the possible syntax nodes that you may want to use. Okay, so the first one that I'm going to show you is this scenario, which already have a breakpoint. Very good. It's recompiling because I wrote an override, of course. It's executing now the code. A good old PC. It's good, but it's also pretty old, so you have to be patient. Okay, members, and you see that I have a lot of members here that are declared in my sample solution, okay? And I want to filter them for order. So once I collected all the members, I simply create a link query, and I say, okay, I want just the method declaration. I am not interested in properties. And I want the one whose name identifier contains the filter, so order. And then I take the entire declaration thanks to an helper that gives me also the parameters of the invocation and so on. So I end up in having this nice list that gives me the whole stuff. Okay. So I extracted everything, every method that has order inside it. Cool. We are done with this. It's nothing specifically complex. You have seen that method extractor visitor is very simple. So let's go on and go to this other scenario. And this other scenario is going to take the member and start from process business rules. That is a specific method that we have here. Okay, so this is the method. And we have two references, but they are located under the same method, okay? So let's see what happens. So I basically take these members. I take the only one that is process business rules, and I walk up the tree until I found the referenced one. And it takes a while, okay. And now I have the top members that are this one, and if I make a nice string for that, I basically find just prepare orders. Bear in mind that is extremely important, and start did find two invocations, because inside this, that is not a visitor, by the way. You see, I called it visitor, but it's not a visitor because it's just sufficient to invoke the find caller async we discussed previously in the slides. I receive one reference with each location. So I have one caller, but with multiple locations. So if I want to distinguish the first both invocations, I can. But at this moment, I am not interested because I am just walking up the tree, and I'm not very interested in knowing how many times is called. Okay. So let's go on in this. So we walk it down, then we walk it up. And then we finally have a more interesting example, which is the most important part. And okay. And when I'm here in this visitor, I will basically start from the given method, walk up the tree, and then will descend all the possible trees that I all the paths. These are basically all the methods that are called inside my solution, and they are quite a long number. I mean, they are 93, okay? And you see also the call to next double, list add range, and so on. There are multiple things that happens inside. It doesn't really matter to us at this moment what is doing that logic. I mean, it's a logic that populates some entities. It's very simple, it's straightforward. But the point is that I know exactly what is the sequence of the calls, because I am walking the graph in a specific order. In order to walk the graph in a specific order, the most important thing is that when I visit the node, sorry, the visit invocation, I first visit the base, and then I write my own code, so that I explore the graph, the path first, and then I continue to recurse, because otherwise the visit doesn't happen in the correct order. And once I am here, I visit and I see if there is, I take the full name, and I add to my method sequence, and I recurse on the method declaration as we said before. So this is pretty straightforward. Let's go back to the scenario, which is, by the way, okay, F5. So the second one is that I specifically asked to filter by B's rule, and this is, again, pretty similar. And the idea is, as we switch back to the example, I have this kind of rule, B's rule, okay, is just a tag, nothing more. It's referenced by a couple of business rules. The first is apply an agent rebate, and the second one is the discount, the normal discount. And I don't mind about the implementation. As you see, it did not implement an exception because I am not running this logic. The most important thing is the code at this moment, okay? And since I am not running it, I specifically on purpose left the not implemented exception because I am not running tests at this moment, which, by the way, you should continue to run. I am not suggesting that you should not make any tests. But I am trying to understand the logic before the tests, okay? And my rule is that in my specific domain case, I don't want to apply and discount twice. And I want to find that bad and difficult thing that is, what about if I write some code that applies the discount, and then my code is taken by someone else who doesn't see my apply discount and apply the discount again, but in another piece of the code. And then maybe I want also another rule that is able to distinguish and tell me, yes, I don't want that the agent rebate, which is a discount, by the way, happens before the official discount. Because if you make a discount of 10 plus 5 and 5 plus 10 is different. I mean, you cannot swap the discounts. So the order of the discounts matters. And this is the business rule we are trying to understand. So what I am doing here, okay, again, it's a visitor. And this visitor is starting here with a visit. And I start with the invocation expression on what? On the top, because I have to find most of the story. So I have to start as soon as possible on all the available source code that I have in my solution involving a specific method that is applying the discount. So I go backwards in the graph, I find the top, and I walk to see if there is anyone else that is invoking a discount in my case. And so I walk there, and if the type is tagged, and this containing type is the B's rule, I add to the method sequence that I found someone that is using this B's rule. And as soon as I find the declaring syntax reference, I recurse, and I walk all the graph this way. So what I am finding at this point, I am finding a sequence of 6 apply in the correct order. So if you were going to execute the code that I wrote, beyond the not implemented exception, of course, you will end up in having the execution in this exact order. Okay? So we don't only found the dependency of the calls, but also the order of the execution, which is extremely important. Now what? Now what? The problem is that there is a flaw in the logic of the tool. Because what if I am applying these rules on different instance orders? You get the point? So maybe I am creating in the same logic 2 different orders. And I am applying 3 times on one order and another 3 times on another. And how can I know, since I am doing a static analysis, if these orders and these others are different or not? If you think about it, it's definitely possible, because when you do a code review, you end up in distinguish it, because you see an assignment, okay? You assign the reference. You call a constructor of a new order, or you call a factory of the new order. But you see that there is an assignment of a specific reference that is the one that you are using inside the apply discount. So what is happening here? The point is that I can create a more sophisticated analyzer that deals with a stack of dictionaries that are basically the frames of the identities of the reference that I found inside the code. So if I take all the symbols, I see the types, and I put them in a dictionary by name, okay, it's valid, it's legit, because the name counts, so the dictionary is a good candidate. And every time I invoke some code, I push it on the stack. And then I pop when I come back. I have the exact identity of each variable, each reference that I am using. But I have to do another thing that is extremely important. I have also to rename the name of the variables every time I enter the call, because I pass you an order, but you locally call the variable, or you call it with another name, and you call my order, or O. Okay? So every time you call, you have to map the arguments with the parameters. The arguments are the one on the invocation. The parameters are the one you receive on the local call. And this is what I am doing here, which is pretty crazy. I told you, I advised you at the beginning of the session, you wanted to stay here at any cost, and so you have to bear with me. And now we have this start internal. So I create a frame every time a call is made. We will see this in a moment. So we push the frame, we visit the method, and we pop as soon as we exit. And every time we found an invocation expression, if it's the correct type that we found, of course, we take all the things that we need and we push the method in the method sequence. But with the variable identity, this variable identity is something that I extract specifically every time I meet an assignment that we will see in a moment. And then on declaration syntax, of course, I take all the arguments and I put in all the variables and they recurse. In the assignment expression, basically, every time I don't see the variable identity inside my code, okay, and I extract by name from the dictionary, I am creating a new variable identity, and this variable identity is a class that I created, which every time I create a new one, the ID is automatically incremented. So I distinguish it simply with a number that is indefinitely goes on and on. Okay, once I have the new identity because I assigned the new reference, I recurse, and I am done. And when you have the declaration, the assignment, or the declarator, so var x equal order that you have before, is basically the same task. So this is a code that is pretty much the same as before. The good part is that this is sufficient to track the identity of the references. Of course, I didn't put in my code things like out or anything else that can impact on the variable. So in a production case, you should take into account also those. And the result of the code, of the execution, is that, I have to repeat the execution, of course, is that you have this apply grouped in a different way. So we are loading the solution. The part that is pretty long is loading and compiling the solution, of course, because you see that analyzing is not that bad also because the solution is pretty simple. And once I see the result, you can see that they are grouped by 3. So if in the code, there are 3 applies in different places on one specific order, and then I create and reassign the new reference, and I reapply again the 3. Now, the validation on this business rule is pretty straightforward. It's just up to me to establish if it's legit or not, to respect this order in applying the rules, and whatever else you want to do with that. Does it feel better? Yeah? Okay. We will discuss later in the discussion zone, by the way. Okay. So what we have seen there is that, yes, it could work. It's crazy. It's definitely a strange thing to do because we are simulating the execution, but in a different way. And of course, we will never know if a discount rule is applied multiple times because of the loop. So we have to take an account of this, right? So it is specific to certain scenario. It's not a general rule that we can apply in every case. So it's up to you to evaluate if it's okay or not. So this is basically the way to explain how to tracking the identity of the specific references. So I will jump up this one and let you on the slides. And I want to recommend that the analysis that you can do is obviously broader than the one that you can do with the runtime. But there are limitations. As I said, you are analyzing everything, but you don't know exactly what will happen at runtime in terms of number of loops or many other things, or parameters that you are dynamically creating. If your code is specifically very complex because you are generating code, you are making anything else, okay, you should be very, very careful for this. So it's not a replacement for test, but at least it can give you a first boundary and say, okay, I already found this one. I will leave the other checks in the unit tests so that I have a better coverage of that. And I have another interesting example that is if you walk the solution, and this is pretty nice. If you walk the solution and you end up in having the entire tree, okay, with this member extractor, we take the members, then the process order, and we go to the top members, and we run all this stuff. And we will end up in having this flow1 WSD, which, by the way, is a nice way to visualize the thing. It's a text file that you can see here. And if I go to the preview mode, this is plant UML, which is able to give you a sequence diagram. Oh, now, this is done on all the CLR calls, which is pretty boring. But if you filter out by your specific interfaces, or better, if you go and extract only the calls that make you sense, so for example, pushing something in the bus, you don't know what happens next, okay, from the CLR perspective. So you don't have invocation, but you can reconstruct the flow that you are doing on the bus. And so you can create a sequence diagram on the call that also involve external stuff, so like HTTP calls or even the pushing events or asynchronous calls and so on. So this is extremely interesting because you can really see what is going to happen here. And you have the complete flow regardless of the try, catch, and whatever. If you want to filter out some of the paths, it's up to you. I mean, it's definitely possible. The last thing that I want to show, and I will close very soon, is that there is another use case that is the one where you want to use a kind of eval to generate code and use code provided by the customers. It's something that you should never do, of course, but if you really have to, you can evaluate the source code by visiting it and understanding if it belongs to a namespace that is potentially dangerous. So I don't want that anything from system.io be executed in my code. So if your SDK provides a plugin and you give and the interfaces to create new plugin, you may want to stop any call that is executed in that namespace. And basically, this is what is done with this last example. Okay, let's F5. And I will show just the output, because the rest is pretty straightforward. It's the same way of visiting the invocation and recursing. And on this first piece of code, we have basically, okay, the line and the column, write all text, not whitelisted, and it reports also that the line of code that was stopped. Basically, you're adding some rule to stop the compiler and to inform the compiler that it checks that and you don't want to execute that line. So it prohibits certain calls. Of course, you have to also blacklist something. The whitelisting is always the best strategy, but you also blacklist the activator class, because the create instance can do a lot of damages, and also the dynamic keyword, because the dynamic calls are unpredictable from the source point of view. So these are the two recommendations, and if you want to discuss this thing, I will show additional code about this stuff. So to sum up, I can say it's definitely different, the flow, from the one that we are used to analyze at runtime when we use the tools, or from the one that we normally use as developers with our standard IDE. It's totally different perspective. I mean, we are analyzing something that is specific to our business model, to the domains. So we have call graph, we have sequences, we have the analysis of the dependencies, and especially I want to recommend you not just the dependencies from the CLR perspective, but from our domain perspective, which is far better and interesting. And we have seen the whitelisting and blacklisting from a security perspective. Of course, it may result in false positives. So you have to take it with, you have to be very careful in using it. And but it's definitely something that you can add and provide a better experience as soon as you go on. So of the many things that cannot, be done, I believe that the end of the result that you can obtain is definitely interesting. I hope that you are with me finally with this. It's an idea to explore, of course. It's not something that is a general rule. And I want to thank you very much for your attention, and follow me to the discussion zone if you have any questions. Thank you.